Hello everyone, in this video section I would like to discuss about significant figures, how the origin of the significant figures, how we count significant figures, how we count significant figures in mathematical operations, and how we round the numbers. As we can see, it is a vital, important part of any scientific research. We have to take quantitative observations, and also known as measurements. The measurements are always done against the standard. What that means is always done using an instrument or a set of instruments, and always read from the biggest marks to the smaller marks, and until the marks are not there, so we have to make an estimate. This estimate is always between the smallest marks. As shown here, example, if you have a ruler, and shown here is in the units, is in the millimeters, which means between 1 and 2 are millimeters. And then now you have an object represented here as the green shaded rectangle, and you want to measure the length of this object. As you can tell from here on the screen, it is between 4 and 5. It is between 4 millimeters and 5 millimeters. However, in between here we do not have any smaller marks to guide us, so we have to make an estimate, and it's roughly right in the middle between 4 and 5. It is purely now, it's depending on operator. In this case it's me, so I will make estimate for the length of this object, and the answer will be 4.5 millimeters. The 4 is the accurate number because you know it's more than 4 but less than 5, but 0.5, and that 0.5 here is an estimate. And for another example, as you can show here, it's the same ruler and same unit, the silver rectangle representing another object. However, now you see the difference now is you have smaller markings between each of those millimeters. Now it's between each of those millimeters, as you can count, each smaller mark represents 0.1 millimeters. So as we can see, if we have a smaller mark, and later on I'm going to talk about it in another video instruction, and they will be a more accurate instrument. Means you have smaller marks, we can make a better estimate. Okay, the key thing is always the last number of any quantitative observation, we call it measurements, is actually an estimate. That's where we define it as a level of uncertainty. It's where that point the measurement is becoming uncertain. You have to make an estimate, and in this case it's between 4 and 5. And also you can see, like, I can make more accurate measurement. Now it's between 4.5 and 4.6. Now you know it's 4.5, that's accurate, and you make an estimate what is between the 4.5 and the 4.6. In this case, I made a judgment call, so also right in the middle, so I make the measurement as 4.55 millimeters. As you can see, the last digit, the 4 digit is the accurate one, 5 digit is the accurate one. The last 5 on the 100th millimeters, that's where the estimate is made. That actually is the point where the uncertainty kicks in. So it's the level of uncertainty is defined right on these digits. To kind of really summarize what I was talking about in the past 3 minutes, is measurements are all done with tools, and the value depends on the smallest the subdivision on the measuring tool. What the last digit is always the estimate. So the significant digits, sometimes also you can see, is referred to as significant figures, is defined as all the definitely known digits, the accurate reading ones, plus 1. The final digit, the final one digit that is estimated between the smallest divisions. Only measurements have significant figures. It's only when we do the measurement we can measure it against a standard using an instrument. Those quantitative data have significant figures. Very important rule to know actually. When we say the constants or exact numbers and we regard them have infinite number of significant figures, this is going to become important when we subsequently have to take significant figures into account when we do the calculations. So a dozen exactly 12, and that number 12 is considered to have an infinite number of sig figs. And this one is also 1,000 milliliters equals 1 liter. That's 1,000, the 1, all considered to have an infinite number of sig figs, significant figures. Being able to locate, count significant figures, vitally important, a vitally important skill. So now let's take a look at some examples. Here's a table listed some of the measurements, and on the first column, those are one's measured value. Let's take a look at the first one, 1.07 centimeters. You know the 1 and the 0 are the accurate digits. The 7 is the estimate. So the uncertainty happens is where the last digit is where one has to make that estimate. So the uncertainty level or uncertainty is plus or minus 0.01 centimeters as indicated by the measured value. And the ruler division, in this case we'll measure the length, so we use the ruler. So the smallest division, you can really to be accurate, you will be on the 10th, will be this is 0, so this is indicated on the 10th, so 0.1 centimeters. And the known digit is 1, 0, and the estimate digit will be 7. So let's take a look at the second one, and you can go through that exercise. The uncertainty will be on the 1,000 centimeters, and the ruler division, the smallest one, will be on the hundreds centimeters. Known digits is 3, 5, and 7, and the last one is the estimate. Okay. Then let's take a look at this. What is the smallest mark on the ruler that measures 14.215 centimeters? And then you can start to wonder. And how about a 142? And how about a 140 centimeters? You can start filling in those blanks, and you can suddenly start realizing, you're asking yourself, I kind of need to know the rules. And actually this is coming back to talking about how you figure out how many significant figures are. And in this case 14.15 centimeters, and the smallest mark should be on the 10th, 142 should be on the 1, 140 should be on the 10th. But how are we going to actually realize these are zero count, and we need the rules. So this is the next slide. We're going to start talking about how we count significant figures in any of those quantitative data. You will see, you go to any textbooks talking about sig figs, you will see a bullet points, generally 5 to 7 bullet points. Each one of the bullet points is actually a paragraph. Tell you how to count sig figs under certain situations. So actually I kind of condensed all this and done into this kind of a couple of bullet points. First, we take a look at the number, the value, if there's a decimal point or not. So if there is a decimal point, you start counting from the left to right until encountering the first non-zero digit, and all the digits after that are significant. In the other scenario will be if the decimal point is absent, there's no decimal point whatsoever. So now you actually start counting from the right to left until encountering the first non-zero digit. And all the digits after that will be significant. Still, this is kind of really cumbersome to really put into the application. You really have to spend a lot of time trying to memorize them and try to use them. So then that's a further simplification for this process. And let's talk about, in this case, I used the Pacific and Atlantic Ocean as the example. Pacific, you got to remember on the map. I kind of like geology. I know where the countries are located. So Pacific Ocean on the map is located on the left side. Atlantic Ocean is on the right side of the United States. So, if you're looking at California, you can also use the examples California, New Jersey, California, New York, LA, and New York City. So let's look at the example 1. Now you have this example number. This is the number we're trying to figure out how many sig figs there are. It's 0.0078638. And first, this decimal point is right there. And now you start to see I have to drive, or I have to fly from Pacific to the Atlantic. In this case, from left to right. So now I start drawing an arrow and cross out all the zeros encountered by this arrow until you hit the first non-zero number. In this case is 7, and now you start counting, and all the digits after that will be counted, including all the zeros. Okay, including all the zeros. And in this case 78638. They are sig figs, so you do have 5 significant figures. Okay, so let's take a look at example number 2. Now in this case we have 7863800, essentially 78,638,000. Step number 1, do you have decimal point? The answer is no. So you do not have decimal point. Now you move from the Atlantic Ocean to the Pacific Ocean, in a sense, from right to left. You draw the arrows, and then you cross all the zero out, encounter the first non-zero number is 8, and start counting, and counting all the digits. So all the digits, in this case 8, 3, 6, 8, 7, also 5 significant figures. So now you're looking at, you distill this process down to, take a look at the number first. Does it have a decimal point? If it does, then you follow up with the second step. Draw the arrow from left to right and cross out all the zeros until you hit the first non-zero number. The third step is take the first non-zero numbers as the first significant figures and start counting. Do not stop until you count all the digits, including the zeros. If the number does not have a decimal point, then you draw the arrow from right to left, from Atlantic Ocean to the Pacific Ocean. Cross out all the zeros until you hit the first non-zero numbers and start counting. Now, take a look at some exercise questions. So I want you to pause and take a look at those 7 questions and trying to start figure out how many significant figures, where is the uncertainty level, and where is the estimated digit. And if I want to go further, you can actually ask yourself, what is the last marking on the instrument? So the first one will be 120 centimeters. Does it have a decimal point? The answer is no. So you draw the arrow from the right to the left, and starting counting the first non-zero digit, it will be 2. So you have 2 and a 1. So you have 2 significant digits. The 10th, on the 10th, that starts to be the estimate. That's the uncertainty level, and the estimated digit will be 0. The last the estimated digit will be 2, and the last marking on it accurately will be on the hundreds. So you go through all that process. I want you to apply what you just learned, how you identify the number of significant figures. It is important you get a piece of paper, working through all those problems, and compare with the answers I'm going to show you. So, would like to have you achieve 100% accuracy or understand all the answers here before you move on to the next set of instructions. So now you're equipped with how you count the number of significant figures, and later on you will learn when we do the measurement and the subsequent calculations, we need to start round up or round down, especially when you start to round up the significant figures. We're going to have some situation. The number of significant figures is going to be smaller than we actually get the measurement now, especially when we involve in the mathematical operations. So we need to start to know how we're going to round significant figures. So those are the rounding rules. A rounding is always being done from the right to left. When we count the first significant figures, second significant figures, or third significant figures, it's always counted from the right to the left. And then you're looking at the number right next to the one you are rounding up to. If that number is less than 5, between 0 and 4, leave it. Okay? If it's between 5 and 9, you round up. If it's more than 5, you round up. That's very easy to understand. And one of the most challenging part is this exception. When the digit is exactly 5, and there's nothing following that 5, you have to looking at the digit you are rounding to. If that digit is an odd number, you add to that odd number. If that digit is an even number, you actually do not add, you drop. Okay? You leave it. So it is probably going to be different from this particular aspect that you've been instructed. If it's less than 5, leave it. If it's more than 5, you round up, which including you round up even if it's exactly 5. So I want you to start understand this. I'll give you a further explanation in the next slide. If it's less than 5, definitely you leave it, you drop it. If it's more than 5, it's greater than 5, you round up. However, it is exactly 5, you have to be very, very careful about it. So I really like to take a couple more minutes to give you further explanation on that. Let's use some money example to illustrate this kind of a very special rule. And let's take a look at, if I'm a banker, if I need to round up, if I have $3.25 and 0.6 of a cent, I need to round it up to the nearest cent. Okay, so in this case I have sort of more than 5, so then I will round it to 3.26. However, if I round it to 3.26, I actually added 0.4 cents to the original money before I can round it up. And if I have to encounter this number, 3.254. So I say roughly rounding down because the rule says that 3.25. In this case, I subtracted 0.4 cents. So literally, the net effect for rounding up, if it's greater than 5, or rounding down, if it's less than 5, the net impact on me, the banker, will be zero, because in some transactions I lose money on it, I add money to it. In some transactions I actually subtract to it. So this is nice and handy. But then now we're looking at some examples. If it's $3.255, and if we apply the rule, if it's 5 and above, you always round up. So now you're going to say, I'm going to round it up, 3.26. So actually, as the banker, I add 0.5 cents to it. So now we're going to have 3.265, and to add to it, to 7, I'm still adding 0.5 cents to it. Okay, and so this case is I'm still putting 0.5 cents. Then as a banker, you say, wait a minute, I'm always adding half a cent to it. If I do many of those transactions each day, I'm going to be in trouble. So I need to come up with a rule to actually limit. Some of those transactions I will add half a cent. Some of the transactions I will subtract half a cent. So here actually comes on the need to define that rule. So this is actually coming from the banking. Okay, it's actually a very practical issue, correct? So now it defines. Now it says, if I have this exactly 5, I have to run it to this 5. And I need to create a rule that will be kind of a half and half split between I add half a cent and I subtract half cent. So you can see if this number is odd, I add. So the new rule says that one will be $3.26. Then I'm still doing this transaction. I'm going to add half a cent to it. However, if I have this one now is an even number and that is exactly 5, so I'm going to, the new rule say I'm not going to always do that. I'm going to create another this one is going to drop it, so this one is also going to be 3.26, and in this case, instead of add a half cent, I subtract half cent from the transaction. So now you see, this is actually from the practical perspective, we have to have that special the rule when it's exactly the 5, you want to round it to the digit before it. You have to check if that digit is an odd number, drop it. If that digit is if the digit is odd number, you add to it. If that digit is even number, you drop it. And this is the explanation why. So then let's continue our discussion. Let's move back. Okay. Now let's look at some examples. Example number 1, you have 2.532 and you want to round it to the 3. Then this is the last significant digit you want to round it to, and you have 2 with the last digit. 2 is less than 5, simply drop it, and you have 2.53. Nice and easy. Example number 2, 2.536 now. Same thing, last digit, significant digit. You got a 6 as the last digit. You want to round it to 3. It's greater than 5. And round up. So this one is 2.54. Let's take a look at example number 3, 2.5351. And same, the 3 is the last significant digit. You only want to round the 5 and 1 to it. And now you have the 5, but you have 5-1. So 5-1 is regarded greater than 5-0-0-0-0, right? So this one is actually it's regarded like greater than 5. So you round up, and you got it 2.54. So now take a look at the next example, 2.5350. 3 is the last significant digits, and you now start to decide, now I have a set situation. I'm setting exactly on 5 because 5 is a 5. And you start thinking about, that is what that exception, it's the middle rule, and you can take a look at it. What is the number of the what I'm going to round up to? Then that'll be 3. 3 is an odd number, so according to the rule, you go up. It's 2.54. Okay. Now here comes the exercise side. I want you to pause on this page and take a look at those 6 questions and apply the rules you just learned, how you round significant figures. And you can see for every one of those you can have a specific number of significant figures to round to. And remember, when you count the significant figures, when you start counting, what is the first significant figures, second significant figures, third significant figures, you always count from the right to the left. Always count from the right to the left. Get a piece of paper, work through those problems, and after you get your answers, and now I'm going to show you the correct answer for that. For instance, if you want to round to 2 significant figures for 4.256 centimeters, and 2 significant figures, the first significant figure is 4, second significant figure is 2. So you want to round this to the 10th. 5-6 is regarded greater than 5, so you round 1 up, it's 4.3. So you can go through this one by one and check check with your answer. Some of them are quite challenging, like the number 2, and you can see 3 suffix. The 3 is the last significant figures, and you have to round the 5 up to it. And it's a 500. Now you start looking at it's the special exception. 3 is the odd number, so you round 1 up to it. So you write it 124,000 grams. And finish the rest. And I want you to achieve 100% accuracy before, or 100% understanding before we move to the next section. So as you know, we conduct experiments, we carry out the experiments, collect data. A lot of times actually we have to do calculations based on those data, do data processing, that's what we termed it. And then we need to know how we handle significant figures when the mathematical operations have to take place. There are 2 classes of them, and one is addition and subtraction. And general rule is the answer must have the same number of digits to the right of the decimal point as the value with the fewest digits on the right of the decimal point. You may ask why? Why this kind of the rule? It's really wordy and lengthy. It's because remember when we do the measurements, the last significant figures is indicating is the estimate. This is the uncertainty. So you have a bunch of measurements, you add all of them up together, the sum or the results of the sum of the addition or the results of the subtraction cannot have more precise, more accuracy than the least accurate measurement. Okay, and the least accurate measurement. It kind of makes sense. So let's take a look at how it actually works. I'll get you example: 28.0 centimeters plus 23.538 centimeters plus 25.68 centimeters. And as you said, it started with elementary school math. It's arranged values, so it's decimal point lines up when you're trying to add them up. And now you can see do the sum of, or subtraction. In this case, do sum. This is summation, and it's 77.218 centimeters. As you can see, identify the value with the fields to places of decimal point. Which of this measurement will be has the highest uncertainty level? This one is uncertain on the hundreds centimeters. As you learned in the prior section how to identify the level of uncertainty. The second measurement is on the thousands because it's on the third digits after decimal point. And the first one is only after 10th. So the least accurate one will be on the 10th. So your answer cannot be more accurate and beyond that. So you have to apply the rounding rules, same number of places, and the answer would be 77.2 centimeters. You're running out 2, 1 is less than 5, so you drop the rest. The other class will be multiplication and division. And in this case, it's not the same as addition and subtraction. And the answer must have the same number of significant figures and the measurement with the fewest significant figures. Let's take a look at this in operation, and just remember the rule for multiplication and division is different from the rules for the subtraction and addition. If you take a look at this, is 28.0 centimeters multiplied by 23.538 centimeters multiplied by 25.68 centimeters. So let's carry out the operation, and you can punch calculator for that. That's a big number, 16,924.76352 centimeter cubed. Actually, I got that from a small calculator. I got cut off the digits already. Then now you start identify the values with the few significant figures. This one has 4, this one has 5, and that one has 3. So this one has 3 significant figures. So your answer cannot have more than 3. So your answer has to have 3 significant figures. First significant figure, second, and the third. So your answer has to round up to the 9th. So in this case, round the answer to the same significant figures and can give you the answer, because 2 is less than 5, so you drop everything. But you have to put in 2 zeros. Those are called the placeholders. Those zeros are called the placeholders, tell you the right digits, but they do not count as significant figures. As we learned before, and this number does have the correct number of significant figures. It doesn't have a decimal point, so the arrow should come from right to the left, cross out these 2 zeros, hit 9, and you got 3 significant figures. And that 3 is determined by the least number of significant figures in the number involved in the calculation. So now here comes the exercise. The first 3 questions involving addition, subtraction. The last 3 involving multiplication and division. Get a piece of paper, start working on them, and trying to recall what you learned previously. Okay, so this is the exercise. I want you to really get a good handle on this and compare with the answers I'm going to show you. And those answers are shown in red within the bracket, and those are the answers that's coming through the steps. Carry out the operation, and then for addition, subtraction, identify the least accurate one, which means you identify the highest uncertainty level, and now your answer should be determined by the highest uncertainty level. Multiplication, division, you're going to count. Carry out the operation, then you're going to count each of the numbers involved in the calculation, how many significant figures they have. Pick the least number of significant figures. Then that determines the number of significant figures for your answer. I would like you to have very high percentage, 100% correct answer or 100% understanding before we move on to the next section of the discussion. Okay, so thank you very much for your attention. Please check the homework assignment for additional exercises.